Having a happy ending depends on what it takes to make the equation happy. Now you can simplify and solve, but there are a few more things you need to know in order to find the happy ending to every equation. We'll start with something simple and practice a way to think about equation solving that will work if, or rather when, the equations get trickier. Let's start with something simple like example 1, and let's make a point before we go any further. Don't get sidetracked wondering why I chose 4x plus 5 equals 2x plus 11. There are a lot of equations that I can choose when teaching. I pick the first one I think of that I think will work. So study the examples. Don't worry why I chose them. Now where were we? Example 1. Solving 4x plus 5 equals 2x plus 11 is something that students don't hesitate to just jump right in and solve. The algebra is very straightforward, and the answer is very comfortable, x equals 3. However, thinking about this problem will make it easier to think about the next one. Of all the real numbers that x could equal, how many can I find that will make 4x plus 5 equal 2x plus 11 true? What x or x's will make 4x plus 5 and 2x plus 11 have the same answer? According to the algebra, we found out that x was x equals 3. 4x plus 5 came out to be 17. 2x plus 11 also came out to be 17. If you choose any other x and plug it in, 4x plus 5 and 2x plus 11 will not be equal to each other. The next 4 examples have surprise endings because I made very strange equations. That doesn't mean because they're strange that they're not legal equations. They're just strange equations. Example 2, 4x plus 5 equals 4x plus 5. Here's where the think sentence comes in handy because there's really no work to do when you write 4x plus 5 equals 4x plus 5. Of all the real numbers that x could equal, which ones will make 4x plus 5 equal 4x plus 5 true? The answer is every number works. When x is negative 5, you get negative 15 on both sides. When x is equal to 4.5, you get 23 on both sides. If the 4x plus 5s are identical, the answers they make will be equal. And as soon as you see an identical equation, which we call an identity, you stop and say the solution set is all real numbers, meaning that every number works. Of course, equations are rarely as obvious as example number 2, which is why I wrote example number 3. So pause for a minute, take out your worksheet, and work out example number 3. Turn this back on when you've got an answer. Yup, once you sort it out, example number 3 ends up being 4x plus 5 equals 4x plus 5, and the solution set is all real numbers. It's very rare for an equation to be as obvious as example number 2 was. Very often they're disguised, and until you actually do the work, you have no idea what you're going to find at the end. Have you ever noticed that instructions sometimes say solve if possible? And even if they don't say solve if possible, the truth of the matter is that no equation is ever guaranteed to be solvable in the sense that you can get a numerical answer. Example number 4 is one of those. 4x plus 5 equals 4x plus 11. How can the same 4x have 5 on one side and 11 on the other side and ever hope to be equal? These expressions can never be equal. This is called a contradiction because it's impossible to get a numerical answer. Most kids, however, like to do some work before they're ready to make a final decision. So either you can subtract 4x's from both sides and get 5 equals 11, which is wrong, or you can subtract the 5's before you subtract the 4x's and get 0 equals 6, which is wrong. No matter how you do it, the equation will never work. And because it's always false, we say that it has no solution or that the solution is the empty set. So far, we've seen 3 things that can happen when equation solving. It's a straightforward problem with an answer that makes you feel comfortable, and it's what you're used to seeing. However, the x's can cancel out completely, and all that's left are the numbers. If the numbers are true, then all real numbers will solve the problem. If the numbers are false, then it's no solution. Just follow the math. It will never let you down. In order for you to be prepared, there's one more example I really think you need to see, an example where the numbers cancel out rather than the variables. Here's example number 5, 4x plus 5 equals 2x plus 5. Without thinking about it, you just subtract 5 from both sides so you can isolate your x's, and then all of a sudden, 4x equals 2x, the numbers are gone. That's when kids tend to freak and start making things up. They do all sorts of strange things that are really not algebraic and get all sorts of strange answers. Algebra will never let you down as long as you follow the rules. And the rules are isolate x by moving all your x's to one side of the equation. So I subtracted 2x from both sides and got 2x equals 0. When I divided both sides by 2, I got x equals 0. X equals 0 is always the answer you get when the numbers cancel out and only the variables are left behind. So now we know. There are 4 things that can happen when solving linear equations. A typical equation gives you a value for x. An identity gives you all real numbers. A contradiction gives you no solution. And when your numbers cancel each other out, and all that's left is the variables, you're going to end up with x equals 0. Remember also that numerical solutions, when they exist, can be fraction or decimal, positive or negative. The fact that all you saw here was 3 and 0, 2 nice, neat little numbers, doesn't mean that that's what always happens. Just be prepared, do the math. Don't assume you know what's going to happen until after it happens. The type of equation solving and simplifying we just reviewed is called linear because none of the variables have exponents. And the reason I put the words have exponents in quotation marks is because all variables have exponents. The exponent they have is 1. Because the exponent is 1, you never see it, and because you never see it, it sort of doesn't really affect the problem very much, which is why linear equations are often spoken about as if they had no exponents at all. What you may not have noticed, though, is that every example so far had only one variable in it. What if we had 2 or more? Good question. That's for another worksheet. Hope you're enjoying the math. Hope you're finding it fascinating. I am having a really good time here. See you again soon.